Good morning to one and all. Respected Father Matthew, Principal, distinguished guests, dear participants, ladies and gentlemen. Today we have logged in this webinar to know and reflect more on the topic of the day. And we have an eminent speaker lined up for today's webinar. With this brief introduction, I would like to welcome our chief guest and resource person of this webinar, Dr. Nirmal Joshna Garu, HOD of Physics and Electronics, CHSD, St. Teresa's Autonomous College for Women, Eluru, to share her views on the topic of the day. Welcome, dear Madam, for this webinar on behalf of Deepal Colleges. I thank you, Madam, for accepting our invitation, and we are eagerly waiting to listen and learn from you. I extend my heartfelt welcome to our principal, Father Matthew, for encouraging us to conduct a webinar like this today. We are thankful to your Father for your kind support, suggestions, and guidance given to us as and when required. I feel honored to welcome all the participants who are logged into this webinar. Thank you all for joining us today for this wonderful event. Once again, I welcome you all to this webinar and hope that you all will have a great time ahead. Now I invite Mr. T. John Wesley, HOD of Physics, Deepal College, to give a general introduction of our college topic as well as of guest speaker, Dr. Nirmal Joshna Garu. Over to Wesley, sir.
Good morning to all. Heartily welcome to the webinar organized by Deepal College, Eluru. This is T. John Wesley, Head of the Department of Physics, Deepal College, Eluru. Dear sirs and madams, thank you for joining us. We are happy that you are with us today. Deepal College was established in 1991 in Penacademy village for improving the standards of rural students who are poor economically. Deepal College is run by Deepal Educational Society, belongs to Vincentian Congregation, which is an international missionary community established in the year 1904 in Kerala. Now, Deepal College is one of the leading institutions in West Godavari district, Andhra Pradesh. Today's webinar titled Impact of Aerosols on Climate is conducted by the Department of Physics. The main aim of conducting this webinar is to understand the recent developments in the field of atmospheric aerosols and aerosol science. An aerosol is a suspension of fine solid particles or liquid droplet on air. Natural aerosols are fog, mist, dust, etc. Atmospheric aerosols scatters incoming solar radiation, and a few aerosols absorb solar radiations. It causes cooling and warming effects. Eminent speakers always gives us true knowledge and a clear explanation of the topic. Now I welcome our chief speaker of the day, Dr. Nirmala Josna Garu, Head of the Department of Physics and Electronics, CHSD Terisas Autonomous College for Women, Eluru. She was born in 1962. She completed her PG, MPhil and PhD in Andhra University. She has completed her PhD in the branch of Aerosol Science. She carried out her research work in aerosols at National Research Sensor Center, ISRO, Hyderabad. She received Dr. APJ Abdul Kalam Life Achievement National Award in February 2020 from IISER Bengaluru. The Best Teacher Award from AP Government consecutively for the 2 years 2013-14 and 2014-15. She established and monitored APR and GIS labs and also organized several national, international seminars and workshops and attended nearly 70 national and international conferences and also published 50 national and international journals. In association with ISRO, Madam Nirmala Josna Garu has completed many project works with the participation of many students. For example, Bhavan Panchayat project and geotagging project of Eluru. At present, she is the coordinator of IIRS, ISRO, and Out Research Network Program Coordinator for IIRS and ISRO Dehradun. Under her coordination, more than 500 students completed 10 certificate courses offered by ISRO. Now I hand over to Madam Nirmal Josna Garu.
Thank you very much, sir, for the nice introduction that you have given. Can you hear me?
Okay, madam.
Thank you for your nice words of introduction. And now let me share my screen.
Okay, madam. Continue, madam.
Can you see my screen now?
Okay, madam.
So, a very fine morning to all the participants, all the organizing team who are here with me today. So today I am going to discuss the topic on impact of aerosols on climate. Here, it's a big question for the entire world. And the major problem that the world is facing today is severe and unpredicted climate changes. These climate changes, they are different in different regions. So everywhere we can hear the problem that there is El Nino, La Nino, missing out of rains, and then we are also hearing the hurricanes, tsunamis, eruption of volcanoes. All these are creating unknown climates, unknown climate and unpredictable climate changes over many places all over the globe. So this has become a major problem for everyone. So it is important that we should make a study, and all over the world, the entire scientific community all over the world has taken up this research, and many scientists are working towards the estimation or the causes, the key causes, and what is happening in the aerosol climatology, and what are the key physical and chemical processes that are governing this global radiation, and what is leading to this drastic climate changes, which is even affecting the stock exchange. We see this cyclone has occurred here, some volcano has erupted, then suddenly the stock exchange shows the Sensex reading falls down. Now, what are these aerosols? Though it's a very tiny particle, these tiny particles have a very big impact on the climate. These aerosols, they are suspended in the air, very tiny particles, but they are having large impacts. They are occur in different sizes, and they also have different properties. Like they have they have both positive effects and also negative effects, and they are also uh, they are all also of different modes, like accumulation mode, absorption mode. They have reflective properties. So here it is very important that we should study the sources of aerosols. What is their transport property? How much time is it residing in the atmosphere? And how are we going to control this? All this has become a major part of the study of all the scientific community around the world. So here, aerosols are tiny particles suspended in the air. It is one of the major particle in the atmosphere, and it plays a very important role in the estimation of Earth's radiation budget. Evaluation of climate forcing by aerosols, it requires the knowledge of spatial distribution, spectral distribution, optical properties, and accumulation properties. All these properties need to be addressed. Here, the spatial means place to place, and temporal distribution, time to time, also is needed. And megacities are the significant sources for aerosols, and it's very important to understand the key chemical and physical processes that control the concentration of such species. We know that in India we are having many megacities like Bombay, Calcutta, then Delhi, and because of the ever-growing population, because of the development of the technology, there are many industries that have risen like mushrooms, and therefore there are many pollutants, effluents, which are emanating from these, and they are causing the aerosol loading. Major aerosol loading is due to these anthropogenic sources in the megacities. So here it is necessary that the megacities, there is a need for the research in the megacities, where what type of aerosols are produced and how much time they are residing and what to be done, and what is the regional scale air quality, and what is the impact on the climate of that city. And they are also affecting the Earth's climate both directly and indirectly. These aerosols, they scatter the solar radiation as well as they absorb the solar radiation and also the terrestrial radiation. Terrestrial radiation is nothing but the radiation absorbed by different objects on the Earth. Now, coming to the sources of aerosols, there are natural sources and also anthropogenic sources. So natural sources are nothing but they are from dust because of the deserts and also from the vehicles, and then sea dust, then storms, and also in the oceans, oceanic dust. These all, and from the eruption of the volcanoes, all these come under natural aerosols. And coming to the anthropogenic aerosols are nothing but man-made, and they are due to the vehicles, vehicular pollution, the industries, and then sometimes they burn the garbage, or sometimes the crops are burned, and continuous fire, forest fires. Recently, we have observed that in Australia, from months together, there were fires spreading in the Australian region, and they are adding a lot of aerosols, especially black carbon aerosols are introduced into the atmosphere. Now, this also is related to the types of aerosols only. We can see salt from the sea spray and the bubbles and the clouds. And again, the aerosols are coming back through clouds and precipitation. Then we have wind-blown dust, then the fossil fuels and biomass burning. And here we can observe the eruption of the volcano, where a lot of ash and sulfur dioxide is let out into the atmosphere. And usually tons of sulfur dioxide will be released into the atmosphere, which brings about a drastic change, and it even causes death of population. Now let us look at, during 1991, there is eruption of Mount Pinatubo, And this eruption has led to a lot of sulfur dioxide, nearly 20 million tons of sulfur dioxide has been released into the atmosphere. And it has risen up to 20 kilometers high into the atmosphere, and it has caused a widespread destruction, and there was a loss of human life also. These gases and solids injected into the stratosphere circled the globe for nearly 3 weeks. So volcanic eruptions of this magnitude, they impact the global climate largely. Of course, they reduce the amount of solar radiation reaching the Earth's surface because they act as absorbing aerosols in the troposphere, and therefore they also affect the atmospheric circulation patterns. Major eruptions cause Earth's radiative balance is disturbed, and they cause what is called as radiative forcing. And this radiative forcing due to Mount Pinatubo, according to the researchers, it was found that the global climate has changed, or the changes were observed up to 2 to 3 years, just one day eruption. And George Stenkikov, a research professor of environmental sciences at Rutgers University, says that volcanic eruptions cause short-term climate changes and contribute to natural climate variability after a lot of research work. Now, this is the satellite picture. This is the picture taken by total ocean mapping spectrometer on Nimbus 7, the satellite Nimbus 7. And here you can see on the same day, the red area observed, you can observe that it is up to 300 milliatmosphere centimeters. That is the sulfur dioxide that was emanated. And this sulfur dioxide, after getting into the atmosphere, it combines with the other chemicals to form sulfuric acid, and therefore there are after effects are very severe. So this is the picture from the satellite. Now, coming to the types of aerosols, there are many types of aerosols. That is the tropospheric aerosols, stratospheric aerosols, then we have sulfate aerosols, carbonaceous aerosols, and dust. We know that the atmosphere is divided into many atmospheric regions like troposphere, stratosphere, mesosphere, and then exosphere. Here, the aerosols in troposphere and stratosphere are very important in changing the climate of an area. So man-made aerosol particles, especially anthropogenic particles, will be in this tropospheric aerosol, reside in troposphere. And stratospheric aerosols are by volcanic eruptions, and they are at a little greater height. And then we have sulfate aerosols, carbonaceous aerosols, and also dust, mineral dust aerosols, which comes out from factories. It will both scatter and absorb solar radiation, and the silicaceous fraction will strongly absorb the terrestrial radiation, which is a good sign that it will reduce the temperature of the Earth. Now, the sizes of the aerosols, they range from 10 to the power of -8 centimeters to 10 to the power of nearly greater than 10 centimeters. And these 10 to the power of -8 centimeters of size are very small. They have large Brownian moments, and they coagulate very quickly with the larger particles. That means their residence time is short. They coagulate to form larger particles. And 10 to the power of -6 centimeters, they are mostly stable particles. They have some reasonable residence time. They have slow coagulation capability in the atmosphere. And direct viewing is possible with electron microscopy. And 10 to the power of -5 centimeter radius, these particles are considered to be large, and they can be affected both by Brownian movement as well as due to gravitation. They'll settle down, and they're likely to, they have the longest survival in the atmosphere. And they also change the climate a lot. And then coming to 1 micrometer, which is 10 to the power of -4 centimeters, these are the giant particles. And then we have 10 to the power of -3 centimeters or 10 micrometers. They are of the size of the cloud droplets, and they have the falling speed of about 2 centimeters per second. Then we have 10 to the power of we have another size, and this one, the next size, they are absent, at least they are 10 to the power of -2 centimeters, that is 100 micrometers, and they are absent or they are rare They are present only if there is a dust storm or there is some violent episode. Usually in the desert areas like Rajasthan, we see this type. And then we have 1 millimeter size, 1 centimeter, 10 centimeter, 10 centimeter size, or occasionally hail particles. We hear about this and they are reported. And severe damage will be caused by those hailstones. We hear in the news that so many times when these hailstones are falling, many crops are getting damaged. Even agriculture, the impact of aerosols is very large, not only on people, but also on agricultural sector also. And then greater than 10 centimeters, they are very rare. And this is the upper limit of the atmospheric particles. Even aircraft, meteorites which fall, and then the volcanic fragments, all these will be larger than 10 centimeters. So here I am discussing about the size because the sizes are very, very important. The size, depending upon the size of the aerosol particle, the light which is absorbed or reflected depends. The wavelength, certain wavelength only will be absorbed or reflected depending upon its size. Therefore, size distribution, study of size distribution of the aerosols in a particular region is very, very important. So what happens? What type of impact does it have? It is, if this size, they have the health risk for the people. So they show that they are usually entering into the respiratory tract of the humans, and therefore it is causing severe illness. Like there are premature deaths and sometimes asthma and acute respiratory syndrome, and also sometimes lung cancer. It is leading to lung cancer. So pollution is showing a large impact on the human health, and that's why it's of a very great concern. The study has to be taken up to control these aerosols. And here we can see that these aerosols can be mainly divided into three modes, that is nuclei mode, whose sizes are from 0.005 micrometers to 0.1 micrometer. Accumulation mode particles are from 0.1 to 3 micrometer, and coarse particle mode are from 1 to 100 micrometers. Particles in the nuclei mode and accumulation mode are considered to be fine particles. Now, coming to the health, just now we have discussed about the impact that it is showing on health. Of course, it is a major concern of public health. And this air pollution has both short-term effects and long-term effects. And aerosols, they cause the cooling of the Earth's surface immediately below the surface. And these aerosols cause cooling effect because they reflect the sunlight back into the atmosphere. That's why they have a direct cooling. And they reduce the amount of solar radiation that reaches the surface. When the air in the atmosphere is loaded by these aerosols, most of the solar radiation, which is coming from the sun, will be absorbed by these aerosols. Therefore, there is a cooling effect. And they are also believed to have an indirect effect on the climate by changing the properties of clouds. Cloud properties also depend upon these aerosols. Aerosols are the cause of the formation of the clouds, and they also decide the residence time of the clouds in the sky. So they have a very large impact on cloud formation and cloud transformation and cloud distribution also. Then the most serious effect is that they destruct the stratospheric ozone. They are acting as a site for the chemical reactions to take place, and therefore they lead to the destruction of stratospheric ozone. We all know that ozone is a layer which protects our Mother Earth and us also from the ultraviolet radiation. But here these aerosols, as they are acting as the sites for the chemical reactions, they are destroying this ozone, and therefore the UV radiation is reaching people, and it is causing serious hazards. During winter, especially in the polar region, they grow to form polar stratospheric clouds. So the large surface areas of these clouds will be providing sites for the chemical reactions, and these reactions lead to formation of large amounts of reactive chlorine, which destroys ozone. So this is a serious effect of concern. Now let's have a look at types of aerosols and what are they doing. Coming to the scattering aerosols, from the very diagram, you can observe that the light which is falling on the aerosols is getting scattered. And therefore, it's causing the cooling of the atmosphere. And you all know that scattering at the lower wavelengths is the result for the color of the sky, blue light. So sky appears blue because of this scattering at lower wavelengths. And then then we have another type of aerosols absorbing, and they absorb the solar radiation or the heat, and therefore definitely they cause the effect called as warming effect. So what we can understand from the global warming is that we have more of absorbing aerosols than the scattering aerosols, especially for the aerosols which are given out from the industrial areas. All the black carbons, all these come under absorbing aerosols, sulfate aerosols, and so on. So these aerosols are absorbing the radiation and they're residing in the atmosphere for larger times, and that is why the earth is getting heated. Now, let us have a look at how the aerosol particles are affecting the clouds. They are acting as the seeds for the clouds to form. And you can see the first picture, it is the clouds with low aerosol concentration. Though the aerosol size is large, it's a the cloud, it is acting as a seed, and the second one is having numerous number of aerosols. The size is small, but number of aerosols are more. So this is the one which is needed for the clouds to reside in the atmosphere for longer time. So we need more aerosols. So often they are acting as the cloud condensation nuclei, and without aerosols we won't have much clouds. So you can see the positive side of the formation of the aerosols also here. So they are helping us for the formation of clouds, and thereby the rainfall, which is very important for us. They also affect the properties of existing clouds, and in the presence of high amounts of aerosols, clouds will have more droplets. More droplets are required for the clouds to retain in the atmosphere. Because the cloud droplets are smaller and more, the clouds will last longer and they will be reflecting the sunlight better than before. Therefore, they cause the cooling effect. And as the clouds are reflecting more sunlight, less of the sun's energy will be reaching the surface of the earth, causing the cooling effect. Now, what happens to these aerosols? I'm telling about the residence times are very important, and how are they removed? Of course, there are also sinks for the aerosols. One is the dry deposition and the other one is the wet removal. Dry deposition is after a certain period of time, they'll sediment or they form into impaction, and then there are wet removal processes like rain out or washout, and then they also transform. They change their size, they change their property by coagulation and also condensation. And then residence time, you can have a look at the picture that as the size of the diameter of the aerosol is going on increasing, the residence time in the troposphere to middle troposphere is going on increasing, and after a certain size, it's going on decreasing. So residence time also matters a lot in the study of climate. Now, this is a complete picture. Always in the study of aerosols, it is important to know the variation over many years. So we go back to 1860 to 1980, 120 years record is needed to estimate at what rate the change, there is rise in temperature or any warming effect or cooling effect to study any change. And here we can see that greenhouse gases are tremendously increased after 1980. And also we can see sulfate aerosols also are increasing, and the temperature rise over the globe, average rise is up to 1 degree, which is considered to be very, very large in the scientific circles. Now coming to the radiative forcing. What is this radiative forcing? This radiative forcing is mainly responsible for the climate of any region. So here, radiative forcing from the earth, always we speak in terms of earth, and you know that sun is incidenting energy and it is reaching the earth. Then earth in turn is reflecting energy, and it is absorbing some energy, and it is earth also is emitting some heat energy, and there should be a balance which is called as the energy balance, but it's not balanced always. because of many dynamics of aerosols, the heat is more. If there is a perfect balance, no problem, but the heat amount, the radiation received is more than the energy given out, heat energy. Therefore, this is called as a radiative forcing, and it has a very large impact on climate. So aerosols are contributing to this radiative forcing and thereby causing the change in the climate. Now, as I told, megacities are the significant sources of aerosols. Here I am putting before you the study over Hyderabad. Hyderabad has population has increased or grown by leaps and bounds, and the industries over last 20 years have increased, and vehicles have multiplied, and it is in the prongs of the pollution, I should say. There is industrial pollution, vehicular pollution, and also because of its geographical location also, it's a dry area, and therefore there are certain dust aerosols, and all these combined together, it was felt that it's very important to study the key physical and chemical processes of these aerosols, or the local generated aerosols at Hyderabad, and what type of aerosols are they, in what sizes are they, how much time they are residing in the atmosphere. All these are of major concern, and therefore the study has been taken up at Hyderabad, and many scientists are working on this. Even ISRO, National Remote Sensing Center, ISRO is working on this to estimate the climate impact of aerosols on climate of Hyderabad. And here, the study area, this is the satellite picture of the study area, and here you can observe this is the Hussain Sagar, full of pollution, and here we have this Musi river, this red one, and then on the top you have number one, it is measuring site, National Remote Sensing Center, and here is Charminar. And Hyderabad is situated in between 17 degrees 10 minutes north to 17 degrees 50 minutes north latitude, and 78 degrees 10 minutes east to 78 degrees 50 east of the longitude. And NRSC is situated at 17 degrees 28 minutes north and 78 degrees 26 east at 512 meters altitude. These latitude, longitude location is very, very important, because when we make the measurements at the ground level, we also compare with the satellite data. We know that many satellites are on board making measurements regarding these aerosols, as atmospheric study has become a major concern all over the globe. And therefore, if we have to retrieve the satellite data regarding these aerosols, we need the location. When we are making a measurement at the ground at that certain latitude and certain longitude, we also have to take the satellite data pertaining to that latitude and longitude, because when the satellite makes a passover in that region, it gives the data related to aerosol. And now, what is this optical depth? It's a parameter which quantifies the attenuation of the sun's beam. A total optical depth of 1 would attenuate by a factor of 0.368. So it's a quantitative measure of the extinction, that means fading away, of solar radiation by both by aerosol scattering and also absorption between the point of observation and the top of the atmosphere. So it's more or less, in simple terms, we can say that it is like aerosol loading. How much of aerosol is present, aerosol content? It can be measured from the ground through the measurements, and the important instrument to measure this aerosol optical depth is called as sun photometer. And routine ground-based observations must be taken daily, on daily basis. Whenever the sun is clear, whenever the sky is clear, the sun will be scanned and the data will be recorded. So routine ground-based AOD observations are of utmost importance for the calibration of AOD retrievals from satellites. In addition, we also want to correct the aerosol effects from the other satellite products. We see how much they are correlating with each other. And if they are not correlating, what are the other effects which have to be eliminated will be taken into consideration. So both are very important in the study of aerosols. we need to make ground-based observations as well as satellite data has to be taken into consideration. So here, I want to show you the instrument which is called as microtops 2 sun photometer, and the other one is called as the ozonometer because it gives even the value of the total ozone, columnar ozone from the position of the instrument to the top of the atmosphere. So using these two instruments, the data has been collected, and the photometer gives the aerosol optical depth values at 380 nanometers, 440, 500, 675, 870, and 1020 nanometers. So now, on what formula is it based? It's I equal to I naught e power minus m delta, where I is solar irradiation at a given wavelength, and I naught is extraterrestrial irradiance, and m is air mass, and given by 1 by cos z, and z is the zenith angle of the sun. It's nothing but zenith angle of the sun is the angle between the straight path from the instrument to the sun and the zenith of the earth. So delta is the total optical depth. Now coming to the other instrument, we need to assess the UV also. We know that ultraviolet radiation is very much important, and this ultraviolet radiation, if it is falling on the humans, if it is more, it will cause severe damage to human skin. Skin cancer is also possible, and therefore here this instrument measures UVA and UVB radiation also. Of course, this UVA and UVB radiation can also be got from the satellite products. Of course, this is mandatory, and this we are having in our college also, recently established by the management, and it is under the supervision of physics department. And here we have an air temperature sensor, relative humidity sensor, day length sensor, global radiation, barometer, which gives the pressure, and it gives the wind speed and wind direction. Here, wind speed and wind direction will be taken into consideration when we are studying the aerosol dynamics, because we will see how the aerosol optical depth is changing depending upon temperature, depending upon pressure, wind speed and wind direction. Therefore, this is a meteorological station, and this will it's not automatically it gives the values round the clock. And this is a very important instrument, athelometer. And Hyderabad is full of black carbon. And this athelometer, it will give a measure of the black carbon aerosol every 15 seconds. And it makes, it sucks in the ambient air through the filter. And this air is being drawn, and at a constant airstream velocity, the rate of deposition of black carbon on the filter is proportional to the concentration of the aerosol. And later, every 15 days or 1 month, we can remove this filter, and we can also go for a chemical study. What are the types of aerosols that are filtered in this? What type of aerosols are prevailing? So this is also at a National Remote Sensing Center, and it works round the clock. And black carbon estimation, black carbon measurement also is very important in the study of a climate. Now, what are I was telling that satellite data products are also very, very important. Here, in this study over Hyderabad, total ozone mapping spectrometer Earth probe is a measuring instrument which is placed on board Nimbus 7 satellite. It was launched in 1996 by NASA Goddard Space Flight Center, and it has been in the atmosphere till December 2006. And it was giving all the values of aerosol optical depth. And here, the backscattered radiation is taken into consideration. At 6 wavelengths it takes, and then it's penetrated. What is this backscattered radiation? It is a solar radiation which penetrated into Earth's lower atmosphere and is then scattered by the air molecules and back to the stratosphere to the satellite sensors. That is how the mechanism. So along that path, a fraction of UV will be absorbed by ozone. By comparing the backscattered radiation to the observations of incoming solar energy at identical wavelengths, the scientists will calculate Earth's albedo. what is this Earth's albedo? The ratio of light reflected by the Earth compared to the light that it is receiving is called as Earth's albedo will be calculated, and it's measured and it is recorded by the satellite, and the data product is with NASA, and they are used to derive the amount of ozone above the surface. Then how does it make the measurements? It makes measurements every 8 seconds. Each will cover 30 to 125 miles wide on the ground, strung along a line perpendicular to the motion of the satellite, and almost 2 lakhs daily measurements covered every single spot on the Earth, except near the poles. And over NRSC, the past period of this Nimbus satellite was at 130. So the measurement is compulsory. The measurement at 500 nanometers at 130 is mandatory. If we need to compare it with the satellite data, we need to. And then after December, it has been replaced by ozone monitoring instrument. And the measurements were taken from ozone monitoring instrument. It is a continuation of this terms. It is on the satellite Aura. It is an Aura product. And here we are having, it gives all the products, total ozone, AOD, aerosol single scattering, NO2, SO2, and all these which are necessary for the study of the climate. Then it derives its heritage from NASA's total ozone TOMS instrument, which we have discussed, and the European Space Agency Global Ozone Monitoring Experiment Instrument on ERS-2 satellite. It can measure many more atmospheric constants. Just now I have discussed. OMA instrument can distinguish. The additional feature is that it can distinguish between the types of the aerosols such as smoke, dust, sulfates, and it measures the cloud pressure coverage, and therefore we can even derive tropospheric ozone also. Ozone studies are also very important. They are of major concern to all the scientists working in this climate area. Now let's have a look at this diagram. It is on any other day like April 4th, and there we can see the aerosol optical depth over starting from morning to evening. At all the wavelengths, you can observe that there is a peak at 1 o'clock where it is during lunch break. During lunch break, the anthropogenic aerosols have grown suddenly shooted up, and therefore we can see a clear peak showing loading of aerosols at that time. All the wavelengths, all the aerosols at different wavelengths. And also here clear is, down is a picture which is showing the variation of air temperature on left y-axis, wind speed, and also relative humidity is there. Relative humidity is also taken into consideration. And here you can observe that as the air temperature increases, when you correlate with the top figure, as the temperature increases, the aerosol loading is increasing. As the wind speed increases, aerosol loading also increases. But as the relative humidity increases, the aerosol loading decreases. It has a reverse effect. So significant variations are observed during the source. Yeah. So we can see there are certain turbulent processes along with the increase of the temperature. They are lifting the air particles, and therefore aerosol optical depth is small. And time variation of air temperature, relative humidity, and wind speed are in synchronous with the sun photometer observations. So they are coinciding with the monotonic increase of the air temperature, which leads to gas to particle conversion during at high temperatures. It's possible, and higher wind speeds, which result in horizontal advection of pollution, leading to higher aerosol column content. Now, I told you that the data, this is a large data taken from 2001 to 2006. This is one graph, but data is very large, and we can observe that over the years, the aerosol optical depth has increased, and also in the middle, suppose you start from this 0 to 2001, in the between, that is during summer season, the aerosol optical depth values are increasing and then decreasing during winter, again increasing and decreasing during winter. So as a temperature of our Indian climate, you know that from March, the temperature increases, especially in Hyderabad. From March it increases, and about June the temperature starts decreasing because of rains, and aerosols also are washed away. Therefore, you can see the peaks during summer. And this is the aerosol optical depth. A red color means very high aerosol loading, and orange is somewhat little smaller value. So here these are the months on the x-axis. 2001 study, 2002, 2003, and 2004. You can observe during April, in all the years, the aerosol optical depth is very, very high because of the high temperature. The chemical reactions are more, and the aerosol loading is more, and dust is more, and therefore you can observe almost in all the years the during March and April aerosol optical depth is very, very high. And this is during the other 2 years, and here you can see by the aerosol optical depth. And here aerosol index, satellite also gives the value of total ozone mapping spectrometer, also gives all over the globe at any point. If we know the latitude and longitude at that region, we can know the aerosol index value, and aerosol index value is calculated on the basis of the formula 100 log to the base 10 I 360 measured. It is a measured value, the ratio of measured value and calculated value according to the formula. And calculated is it is a radiance for a pure Rayleigh atmosphere, that is at lower wavelengths, and it is for smaller particles. Actually, the radius is very, very small, and under most conditions aerosol index is positive for absorbing aerosols, and it is negative for non-absorbing aerosols, that is pure scattering. So by looking at the aerosol index values from the satellite products, we can say whether it is an absorbing aerosol or a non-absorbing aerosol. So if we have a positive aerosol, positive value of A, it means that that area or that latitude, longitude in the grid is having a absorbing aerosol, and it is negative for the non-absorbing aerosol. There will be cooling effect if they are non-absorbing. And now these values have been taken from 1998 to 2006 from the total ozone mapping spectrometer. We can observe that, interestingly, during 2003, the values are very, very high. In if you during 2003, 2004, it was called a drought year. There were no rains. Rains were missing during that season, and therefore you can see that aerosol index has shooted up, and it's very, very high. And now I was talking about the importance of taking ground measurements as well as satellite measurements, satellite values. Now, how far are they coinciding? So we are measuring from the ground at a particular location, and then at that particular latitude, longitude of say NRSC, what is the value of aerosol index given by the total ozone mapping spectrometer on board Nimbus 7 satellite. So when it is compared, it was observed that they are in almost, the values are closer to each other. In all the plots, you can observe that there is not much variation. They are showing the correlation. The correlation coefficients are nearly equal to 0.9022 in one figure also. Now, let's see impact of Deepavali on aerosol loading. And we all know that it is an important Hindu festival where all the Indians will be celebrating Deepavali with all the firecrackers, and this is tremendously increasing the aerosol loading in the atmosphere. So this is during 2003, where Diwali was on 25th October. So when the measurements were taken on 23rd October, 24th October, the black carbon values were taken, and when plotted as a graph, we can observe that there is a sudden rise of black carbon aerosol, which is very dangerous for human health. And residence time also is very large, and therefore the temperature also at Hyderabad increased during that period. Therefore, on 25th October, you can see that the temperature is very, the black carbon concentration is very, very high. And it did not come back to the value as on 24th October. Actually, if it was staying for a shorter period, it should immediately come back to the value as on 24th October. But on 26th October and 27th October and 28th October also, for 3 days, the black carbon was remaining in the atmosphere, which is not a good symptom. And then this diurnal variation means, diurnal variation is nothing but time to time variation when you observe on the 3 days. 24th October is a dotted line, which is far below in the second figure. And 25th October, you can see the solid line, how much it has increased over the entire day it was there. And coming to 26th October, it did not come back to the lower level, but it was somewhere in the middle. So this shows how much this festival is loading the atmosphere with very dangerous aerosols. Now, even it was observed that there was another observation that when the air in the Hyderabad after Diwali, when it was completely loaded with this black carbon aerosol after Diwali, I told you that it has even a positive effect. It has stopped UV radiation. Therefore, UV radiation has been absorbed by these aerosols. And therefore, the UV ground reaching UV radiation has reduced, of course. Then what type of particles are loaded? Accumulation mode particle are more in the event day compared to the pre-event day and post-event day. And submicron aerosol mass concentrations are also found to be very high compared to the supermicron on event day and also on post-event day. So we can see this is during 2005. The previous figure was Deepavali in 2003, and this is in 2005. It was on 2nd November. And previous day we couldn't have measurements because it was raining. But the previous day that we could make measurements was 20th October. 20th October, the values were around 4.5 micrograms per millimeter cube. But on 2nd, they have suddenly increased high values and they have reduced on 3rd November. And this is a second figure, which is below. It's a very interesting result that we have observed is that people are aware that using these firecrackers is loading the air with the black carbon, and therefore compared to 2003, the BC in 2005 is very, very less. And Tom's aerosol index also reflected this is a satellite product, a satellite value. Aerosol index is very low compared to 2003. 2003, it was very, very high. So public are aware of this fact. So this is what I have just now discussed. The pollution due to fireworks has reduced compared to 2003 and 2005. So there is increased public awareness. Now, this is quite an interesting observation. Kerala, we have made a study on 4 sites in Kerala. The 4 sites are Pathanamthitta, Periyar, Palakkad and Wayanad. And they are known for their scenic beauty with rich flora and fauna. And here what happens is there are tribals who will be cultivating. That is called as podu cultivation. So what happens is during the month of March, they burn the forest and there they take up the cultivation. So there was a aerosol data was taken. This is the remote sensing data. This is IRSP6 sensor, wide field sensor, fast color composition with the burnt areas. Burnt areas are shown, and on different days it was taken during March. This is the from the satellite picture and remote sensor data. And above graph indicates that this is only during March the values were taken. In all the 4 areas, 4 lines were there in the graph, and all the 4 areas, they have shown a very high value of Tom's aerosol index, total ozone mapping spectrometer aerosol index, showing that forest fires are occurring. And here, so there is an increased aerosol loading in that area. If aerosol index is high, aerosol loading is very high due to occurrence of the spread of the forest fires. This is the DMSP OLS satellite data analysis from February to March. So after that, also it was observed that there were low values are observed. Low values of aerosol index are observed in those 4 areas. After March, due to rains, all the aerosols were washed out. So these yellow, in that figure, it was not very clear, but this is a Periyar Tiger Reserve. It is somewhere near Munnar, where that yellow area is very clear. This is the remote sensed data. Nighttime fires are taken by the satellite, and such, though in the figure it is very small, a large area has been burnt by this for Podu cultivation by the tribals. And in Periyar Tiger Reserve, we can see the plot is for 2002, 2003 and 2004. And you can observe that in 2004 March, the aerosol index value is very, very high. Of course, the aerosol index value is decreasing towards the end. And this is January. January, if it is blue, aerosol loading is less. And then as it goes on increasing, if it is yellow and red, the aerosol loading is very high during March and April. And because of the rains, again, it's turning blue, lower value of aerosol, optical aerosol index. And that is up to August and September, October, November, and December. It's a very interesting observation. And then coming to India. India in the month of January, it's having very low aerosol loading, February also. But coming to March, suddenly there is a rise. And due to the northwestern area, you know, there is Rajasthan and there is desert. Rajasthan desert is there, and therefore there are some mineral dust coming towards the Indo-Gangetic plain also, and therefore the values are very, very high. It's very hot, temperature is high, aerosol loading is high, warming the climate. And coming to April, they have reduced. Mostly it is maximum during the month of March in that particular year, and even May, June, July. July it started to reduce because of the rains, because the aerosols are washed away by the scavenged by the intermittent rains, that is monsoons occurring. And then September, October, after rains, the aerosol loading is quite very, very less. And this was long back. Of course, now the statistics would be different, much more than this. There are many buses, two-wheelers, three-wheelers, four-wheelers, and lorries and trucks. This has been taken to study the impact of vehicular pollution in Hyderabad. Now, annual mean value of black carbon over the study site during 2003 to 2006, you can observe that this black carbon is mainly from the industries and also from the vehicles also. It's very, 2006, it's almost double the value of 2003. So a very large increase in black carbon. And it was sucked in ambient air by the ethylometer, the measurements were made. And during the study, the people who were taking the readings were surprised to see that at Hyderabad, after midnight, BC value was suddenly increasing. So what is the reason when it went to the roots of the cause? Why there is a sudden rise after midnight is that NRSC is closer, it is 2 kilometers away from the national highway, and the trucks were allowed only after midnight. So when the trucks were entering into the, passing on the national highway after night after 12, suddenly BC values were shooting up, revealing that so much of black carbon is given out by these trucks and heavy vehicles. And below figures, we can see one is a weekend, the other one is a weekday. We can see a lot of change in the black carbon values on a weekend. Almost the activity, anthropogenic activity is human activities are very, very less and the traffic is less, and therefore the values are low, whereas on weekday the values are shooting up. The second peak here shows that by the evening still they are residing in the atmosphere, and because of the winds it is aerosols are again rising onto the top of the atmospheric layer. And this is on 9th April and 10th April. This graph is again a weekday and weekend, and here it is mainly shown to aerosol optical depth values on 9th and 10th. So we can observe when you look at the correlate the upper figure and lower figure, whenever AOD is high, SUV is low, and whenever SUV is high, aerosol depth is low. So both are inverse relation. So if aerosols optical depth is very high, they are all the aerosols loading is high and they block the UV radiation reaching the earth, therefore UV is less. So this is one result that we have observed. Then during this is the values. AOD is from 0.63 to 0.88 and low pollution days 0.49 to 0.81. So it is also corresponding to high and low pollution days. And even the values, the value is median per hour. The reading is median per hour. The unit for measurement of ultraviolet radiation is median per hour. And this is another interesting observation on the day before rain, on the day after rain. Okay, so when we look at this picture, we can see clearly that ultraviolet radiation has decreased after rain because all the aerosols have been washed out, and therefore it's not screening. Aerosols are not screening the ultraviolet, they're not absorbing. Therefore, on after rain, they say that radiation is very, very strong, and it is very dangerous even for human skin also. So now there was a chemical fire accident on 28th December 2005 evening at 5:30, 6:30 hours. It was found that it is a bunker oil, which is the oil which is mixed in the paint industry, and therefore it was black carbon, and they have traveled far from the accident site to mid of India. So that can be seen from this hyperspectral model, NOVA high split model. You can see at different altitudes how the particles are traveling. This is a model picture. At 500 meters height, that red line and blue line is 1000 meters height and green line is 1500 meters height. And you can see the location at which it started, and all the wind-blown pollutants are traveling towards the north and they are polluting the entire atmosphere. And now coming to the BC, levels also were measured on that occurrence of the fire accident. And you can see the values on 27th and 28th and 29th. Black carbon values are very high on 28th, but they're not coming down to 29th to the lower level. They are residing in the atmosphere, which is very, very dangerous. Even aerosol optical depth values reflect the same property. Now, this is the entire global picture, aerosol loading. And wherever there is red, you can say that the aerosols are loading is very, very high, and entire globe is getting affected by these aerosols, and global climatology depends a lot about on this aerosol loading. And so we can see that certain countries, America and certain continents towards the west, they are completely, they are very cool and they don't have this aerosol loading on those days. So this is a satellite picture. And here, this is the from the southern hemisphere to the central India, there is a wind dynamics, and this is the high pressure area and that is the low pressure area where aerosol loading is very, very high before pre-monsoon. Therefore, this is necessary for the monsoons to occur because the winds will be blowing from high pressure area to low pressure area, and the aerosol loading is high before the that is during end of May, and which will help in the formation of clouds and for the rains to occur. So this is one picture. This is the aerosol dynamics. And here, this is, you know that during lockdown, anthropogenic activities are almost zero. No people going on the roads, no vehicular pollution, and the earth has breathed a fresh air, and it is free from the prongs of this air pollution. And also we have also observed that the scientists have been from studies. The Indian Institute of Remote Sensing, Dehradun director says that even the Ganges water has become very, very pure, and the purity level has increased. And here, the difference of aerosol optical depth also is very, very large, because the AOD value has decreased a lot, and even absorbing aerosol optical depth in the second figure, and bottom figure, even single scattering albedo values also are there. But compared to aerosol optical depth, we can see that in different areas, northeast area is having more value of AAOD, and there is a decrease in single scattering albedo. But in spite of this lockdown, some areas are showing high values of AOD, not much difference before lockdown and after lockdown. That is because of the dust from the winds. There are winds. We can't, during lockdown, we can stop the anthropogenic activities, but wind can't be stopped. So due to the wind blown dust also, they are traveling. And so in the central India, you can observe that in the because of the wind blown dust and the mineral dust from Indo-Gangetic plain is coming into that. So this is a positive thing during lockdown that has happened, and it was observed that we are having monsoons at the right time also because of the reduced pollution levels. And this is the same thing at Himalayan region. There is a decrease in absorbing and total aerosol loading over the Himalayan region, except over its eastern parts. Now this is the entire summary, and year by year there is a rapid increase, and there is fastly growing population of Hyderabad. And we are coming to the size range of particles. Actually, this size range of particles also has been studied using an instrument called quartz crystal microbalance, which segregates aerosol size particles. And there is a campaign all over the world on Wednesdays. Every organization uses this quartz crystal microbalance to study the mass size distribution of these aerosols in that particular area. And all the data will be sent to NASA Atmospheric Study Center, and where the entire global data will be pooled at one point to make a study. And even till today, it's happening every Wednesday from morning to evening. As long as the sun is there, the ambient air will be sucked in, and quartz crystal microbalance will be segregating the particles according to their sizes. So according to that, we have made a study on coarse mode and accumulation mode particles. And Hyderabad, we suggest that there are multimodal size distribution, and coarse mode particle loading is very high during summer, and accumulation mode particle loading was observed during winter. And total aerosol mass concentration showed positive correlation with air temperature. That is, it is increasing with air temperature, wind speed, we have seen that. And it has negative correlation with relative humidity. If humidity is more, values are less. So they are found to be influenced by the meteorological parameters. And here the high wind speeds and absence of significant rains in certain periods. For example, in 2003, it has increased the value of AOD. And if there are rains, it is due to, these are called wet removal processes, and they are washed out, and cloud scavenging, etc. And they suggest that over the years, when the trends were studied with both the ground observed data and the satellite data, seasonal pattern is the same over Hyderabad. Okay, it has not changed over the years. Now, so as people, as men, as humans on this earth, this globe should be a place to live in, lead a healthy life. And we are in the nowadays, because of the development of the technology, there is a lot of pollution, and the major pollutants are like carbon monoxide, then we have ground ozone, and then volatile organic compounds, then nitrogen dioxide, sulfur dioxide. These are affecting human lives, and also agriculture sector also is facing a lot of problem. And according to the survey of World Health Organization, more than 4 million people are dying every year only due to these respiratory problems arising due to pollution. So according to the Federal Environmental Protection Agency, there are certain causes of air pollution. And just now I told you, unlike the natural ozone layer is protecting us, but if ground level ozone is occurring, it is very harmful. This ground level ozone occurs when nitrogen oxides mix with the volatile organic compounds. So we have to understand, it is very important to understand the sources of these aerosols. Where are they rising? Why are they rising? And we have to minimize it. So we should reduce the use of automobiles also. Automobiles, if we are using outdated automobiles, or even if whenever possible, better to, nowadays each one is having one car and going onto the road with one car on that car, but better use the public transport. When people realize this and start using this public transport, maybe we can reduce the pollution. And then even NASA has discovered that there are many household plants like gerbera, daisy, peace lily, which remove carbon monoxide from the air. Just like human liver, the common indoor plants actually filter harmful chemicals and dangerous compounds from the air, absorbing the toxins through tiny pores in their leaves and digesting the pollution through their stems. So it is compared with a human liver. And using these natural air filters in your home or office, it will reduce the amount of indoor air pollution. And according to NASA study, the helpful varieties are bamboo palm, Chinese evergreen. And then better to go solar. In India, we have plenty of sunlight. So we can make use of this solar light. So when we are going for electricity, what happens is the electrical utility plants are highest in all the forms of manufacturing. And here nitrogen oxide is generated, which is a byproduct of electrical utilities. And therefore, it is leading to increase in ground level ozone, which is very harmful. And therefore, we can go solar and minimize this electrical utility. So whatever is in our hands, if we can do, then it's better that world will be safe, and we can protect our mother earth, and we can give a clean earth and beautiful earth for our children, for the future generations to live in. So every one of us have a responsibility regarding this. And at this juncture, let me say that here I want to read out, but so in this day of age, conservation is the key. As the ozone layer whittles away, the water supply dries up and environmental bleeding is continuing, and many people are taking a stand and going green. So the option is to go green. Do you know what it takes to do your part? So you should take part in this. And here I want to tell to the younger generations to go for research in this atmospheric studies. And I take this opportunity to tell you that there are many organizations, uh, scientific organizations, and many committees which are working in these atmospheric studies. So it is necessary that the younger generation should take up research regarding these aerosols, because it is there in all the ISRO related organizations, and there are world or every organization, all the space research organizations are spending a lot, sending a satellite into the atmosphere, into the sky, to make a study of this climate by measuring many data products. So here it's very important to encourage the students to take up the research regarding this climate studies. And these by making these climate studies, we can study the sources of aerosols, what are their dynamics, and what can we do. And that will be a very important information to protect our Mother Earth. So we have National Physical Laboratory at which the studies are going on, aerosol studies. We have at Visakhapatnam Andhra University. We have Gadanki Tirupati, and then we have at Baba Atomic Research Center, Indian Institute of Remote Sensing, Dehradun, and then all the satellite products are almost available everywhere. All the satellite products can be got through the net, and NASA is placing them in the in the net. Therefore, you can make measurements regarding these aerosols, and it's very important that the youth should plunge into action and take up the studies regarding this atmosphere and protect our Mother Earth. So I thank the organizers for giving me this opportunity. If there are any questions, one or two maybe I can answer now.
Thank you, madam, for valuable presentation on this subject. We are really enlightened with your reflections and convictions on the topic. Dear participants, this is the time for clarifications. You can raise your questions to Madam Nirmala Josna Garu, or please type your questions on this topic in chat box, or you can mail your questions to Madam mailbox attached to the chat box.
Anybody, sir?
Madam, I have a doubt. Hello,
Yes.
madam.
Yes.
Madam, it was a good presentation, madam. I appreciate that. It was very informative presentation.
Thank you,
Yeah.
Father.
And yes, I was, though it was not my department, physics, but it was very informative. It was very informative for us to understand. Very simple way you have presented the matter, and also it is one of the important subjects that we should discuss. The discussion should be more to be done upon this subject. Madam, could you just explain about little more? Can you just explain about what is scattering aerosol and absorbing aerosol? Could you just differentiate these two aspects, scattering aerosol and absorbing aerosol?
Okay, Father. Scattering aerosols are those aerosols which will be, I should say, they take the wavelength from the particles of lesser size, whose radius is very much less compared to the wavelength, and therefore they are related to Rayleigh scattering, and they reflect the light. Whatever light is radiated from the earth on the path from the sun to the earth, these aerosols, they reflect the light, therefore they are not absorbing any radiation. So what happens is these scattering type of aerosols, they tend to cool the surface of the earth. So they cause a cooling effect. Whereas absorbing aerosols are those which absorb the solar radiation. And if these absorbing aerosols are more in the atmosphere, they will be heating the atmosphere, heating the earth. These absorbing aerosols, there are many aerosols, like mostly these aerosols from the industrial effluents and from vehicles, black carbon aerosols and dust, smoke, all these come under absorbing aerosols. So what happens is when they absorb heat from the sun, and they are more in number on the earth, the heat is contained in the atmosphere, which leads to global warming. Therefore, absorbing aerosols heat the atmosphere of the earth, and scattering aerosols cool the atmosphere. They cause the cooling effect, and absorbing aerosols cause the heating effect. Is it clear, Father?
Yeah. Thank you, Madam. It is clear, Madam. Thank you.
So I thank all the participants for being very good audience. If any doubts, my mail ID is there. You can contact me.
Dear participants, can you ask any questions? Now I invite Surendra Garu.
Good afternoon, one and all. Thankfulness is the beginning of gratitude. Gratitude is the completion of thankfulness. On behalf of DePaul College, I thank this opportunity to propose vote of thanks in the webinar Impact of Aerosols on Climate. First of all, I would like to thank God Almighty for His choices, blessings showered upon us. Now I would like to thanks our speaker, Dr. Nirmal Dosan Garu, for her valuable presentation. Dear Madam, we are really enlightened with your reflections and convictions in the topic. Thank you so much for sharing your valuable time with us, and we wish you every success in your future activities. We are also thankful to our Principal Father Matthew for his support and motivation for the smooth cooperation of this webinar. We are grateful to Father Vineet, Vice Principal, for his continuous guidance and help. A special thanks to the organizing committee, the Department of Physics, for the unflinching cooperation and coordination. Our heartfelt gratitude to all those who participated in this webinar for their active participation and support. Our heartfelt thanks to Mr. Ganesh, HOD, Department of Computers, for his technical support. I would like to say a big thank you to all who are directly or indirectly involved in this webinar. Once again, thanking you all. Next, dear participants, there will be a fill out the feedback form attached to the attached in the chat box, and we will send the e-certificate within 1 week. Thank you one and all. Now let us join with the DePaul anthem.
ज्ञान विचक्षण वरदे डीपोल विद्यावसदे क्रैस्तव शास्त्र विशारद विभवे निस्तुल सेवन निरते वचन सुमंगल प्रसरण सुषमे सुभग सुशीतल निलये जनगण परिचरणोद्यतमादे सुललित मानस भरिदे ज्ञानोचित परिपावन चरिदे ज्ञानधनार्जन मिलिदे दीन जनावन शीलन गुणदे मानव मुक्तिद शरणे कन्यानंदन वंदन निरदे धन्यात्मुसीद मुतिदे जय जय विन्सन दीपोर्तनये जय पर विद्या वसदे जय दे जय दे जय दे जय दे जय पर विद्या वसदे।